Hi, welcome to Notes Plus Me Equals Forever. If you missed our in person workshop on this topic, we've got our recap here for you. So let's get into it. So, there's two types of ways to take notes that are important for every student in college. Now, this is a very specific video to UMBC students, and since we gave this workshop in the spring semester, we're going to be using two specific classes as examples, Bio 141 and Chem 102. Those are our two biggest enrolled STEM classes in the spring 2025 semester. So those are what we're going to be using. So it's going to be pretty specific to UMBC students in the kind of first year bio or chem classes, because the textbooks, the same for bio and chem, and the courses for Chem 101 and Chem 102 are quite similar. So taking notes in class. This is really important. We know this is important. Why is it important? A few reasons. Number one, it helps us stay engaged during a lecture. You can kind of let your mind wander off and then realize you've missed something. But if you're taking notes, it's easier to just kind of stay awake, engaged, and maybe enthusiastic, which is great. Hopefully, you're enthusiastic about the material you're learning, but we understand that that's not always true. But if you take notes, it might help you a little bit. It helps you copy examples. A lot of classes, especially problem based classes like chemistry, math, and physics, they are primarily spending class time going over different types of problems. And so copying down examples is very important to do in class so that you have an accurate set of examples that you can take into your practice problems or your homework. You can also use notes in class to fill in knowledge gaps from your class preparation. So, preparing for class is super important. And this is one of the biggest things we're going to talk about today is actually how to take notes on a textbook reading so that you can go to class super prepared. This is a little bit maybe not what you're expecting in a note-taking workshop, but it's really important and a lot of students have requested kind of a primer on how to do this. And so it's important to us to help students out. So, notes when reading. We're doing a module or watching lecture videos, whatever it is. Textbook reading is the classic example, but we understand that might be different depending on the class you're in. So it's a very different experience from taking notes in class. Why? The first reason is that it's not time constrained. During class, you just kind of have to like listen as hard as you can and just try to parse what's going on, what the professor just said, and write it down as fast as you can in paraphrased words. But when you're reading, watching a lecture video that it's pausable, or you know, preparing for class with a module or something, it's not time constrained. You can do it whenever you want, and it can take as long as it's going to take. And, for every student, that's going to be a different amount of time, and you can control that. So, this is important to remember. Oftentimes, and ideally, perhaps, it's your first exposure to the material. So, this is a way that college differs from high school, is that you're often expected to take in this material before class. So, for instance, in Bio 141, which is the main example we're going to use today, there's a textbook, and Dr. Smith in spring 2025 semester expects you to read that textbook chapter before class as she outlined in the syllabus. So, which is, a contract between you and the professor to understand how you're going to do well in the class. So, it's, you can do it. It's going to take however long it's going to take. It's probably your first exposure to material. It can help you identify your knowledge gaps and know what to ask. So, after you've done this reading, this watching of videos that are, given to you before class, or done the modules. If you're in a chem class that has modules here, it can help you figure out what you still don't know and what you can then go to lecture and ask. And it's kind of an insurance policy for staying engaged during lectures. So lectures can be boring, they can go too fast, whatever. People say a lot of things like that about lectures when they're not prepared. When students come prepared to lectures, they are focused on filling in that puzzle. So that is something that just tends to keep them, kind of alive, awake, alert, enthusiastic a little bit. So one metaphor that I like is sometimes, if you watch a movie that's like a mystery, um, and at the end, when you figure out who did the mystery and what they did to kind of, you know, complete whatever it was, um, to solve it, you sometimes your mind is like totally blown. And sometimes it makes you want to go back and watch it again and be like, let me look for all those little things that were happening in that movie that were clues that I missed because I didn't know what I was looking for. And so you might not be the type of person that likes to watch mystery movies again, but if you are, you kind of know what I mean here. It kind of keeps you engaged the second time through, knowing what's going to happen in the end. Like, how do you get from point A to point B? So that can actually be a way to kind of just maintain your interest in when you actually go to a lecture. All right, so let's talk about taking notes on readings. When I say readings, could be lecture videos, could be modules, anything, whatever your pre-class material is. I'm going to use the word readings to kind of encompass all of that. So think about the medium of how you're going to take notes on the readings. You can take them in paper, in a notebook. You can take them in a document on your device. That might be on a document on your tablet that you use with a digital pencil, or it might be in a document that you type, like a Google Doc. All of those are fine. One other thing that some students like to do in memorization based classes like biology is that they like to take their notes directly onto flashcards, either digital or paper flashcards. And I'm going to give you an example of digital flashcards later. And in the description box for this video is a link to Anki, which is our favorite uh, flashcard digital tool. So you can download Anki for free on any internet browser on your laptop or desktop computer. It might cost money if you try to download an app onto a tablet or a phone, but it is always free on internet browsers, and it is a completely ad-free experience. It's really just super user friendly, and I'll explain that later when I show an example of how to use Anki. But link to Anki in the description box if you want to download it. So, think about what you want your notes to do for you in the future. So, for instance, do you want to be looking at your notes for summaries? Do you want to be, using them for active recall practice? So, the first example, summaries, maybe you want to be taking your notes on paper or in a document. Second example, you want to be using them for active recall practice. Maybe we think about taking notes onto flashcards. It really depends on what you're planning to use those notes for. So think of them as functional and then think, what do these notes need to do for me? And how can I do that the most effectively? So think about the method. You might be taking notes on video lectures, for instance. Don't forget that you're still in control. You have control of the pause button. So pause when you need to make note of something more complex or to look up a definition. You're not in a lecture where you are just zooming through to the end. You are, again, in the privacy of wherever you're doing this. This is your learning experience. Make sure to take control when you need to pause, write stuff down, make sure that you get everything. You might be taking notes on a textbook reading. It helps to go through the chapter as a whole to see what you'll be dealing with. So I want to take a deeper dive into this. Like I said, this is a little bit of a non-traditional note-taking workshop where we actually go into the textbook, we look at what you're going to be seeing and maybe what the most helpful things to do are. So, textbook notes in Bio 141 or Bio 142. Again, this is just maybe not applicable to students after this semester. So, hopefully, you're watching this in the spring of 2025. But if you're not, hopefully, they still have this video or this textbook in Bio 141 and 142. But if not, a lot of textbooks look kind of similar. So, let's go through this one. So, if let's say we got to read chapter 5 for class tomorrow. Okay, there's several sections within chapter 5, but this is the beginning of chapter 5, Introduction to Carbohydrates. Okay, so right here you're going to see the kind of roadmap. And I like to use the metaphor of a puzzle when talking about stuff like this. So when you do a puzzle, usually the first thing you do is look at the picture on the box after dumping out all the pieces. And you say, what is this puzzle actually going to look like? You kind of need to know that. It's going to take you way longer to do the puzzle if you don't know what it's supposed to look like, right? So this is same thing with a textbook reading and learning something. Look at the picture. So this is the roadmap. This is what you're going to be learning. How are we going to do this? And then we're going to do this, and then we're going to ask this, and then we're going to look at these things. Okay? That's helpful. It's just helpful to kind of understand, what am I actually supposed to get out of this chapter? What are my goals? Having goals for a reading helps you stay way more engaged and helps you take really good notes. So, first thing you're going to do is paper, digital document that you're writing with a digital pencil, document, Google Docs, whatever it is, start with 5.1 here. We're going to go one section at a time. That's really important to remember. And I want you to just write down that first learning objective. Describe the structural variations that exist among monosaccharides. That's our goal. Our goal at the end of reading that section is to be able to do that. That is a specific goal, really helpful. It's going to really help you with that reading. It's going to help the reading go faster and be efficient. Okay. Next thing we're going to do, so see here over on the left, we have the table of contents. So we're going to scroll down to the end of chapter 5 where it says chapter 5 review. We're going to click on that and we're going to look at our chapter summary. Almost every textbook in science has something like this at the end of every chapter. Again, we're just doing it one section at a time, so you don't need to worry about 5.2 quite yet. We're going to do 5.1 right now. I want you to read this. Now, I'm guessing that if you haven't read the textbook chapter yet, this is going to look like basically like Greek. You know, you can read all these words, but you probably have no idea what a lot of them mean. That's fine. Actually reading this, you're going to understand, okay, by the end of this chapter, I need to know what monosaccharides are. I need to know what a carbonyl group is and a hydroxyl group. I don't, you know, I'm going to need to understand aldose and ketose configurations. I'm going to need to know the, molecular formula of monosaccharides, and I'm going to need to understand how the functions are different based on the spatial arrangement of their functional groups. I'm going to need to understand why they form ring structures. Okay, there's a bunch of things that I am reading here that probably don't make a whole lot of sense yet, but actually reading them and like thinking about them for just a second, like, okay, I don't know that, but I need to know that by the end. Um, it's going to just kind of put the Velcro strip down on your brain that is going to help all that material stick. So I like to say that priming your brain with things like this is like putting the one side of the Velcro strip down, and then actually reading it is like putting the other side down. It's going to stick. But if you don't put that sticky strip down, the fluffy side of the Velcro doesn't have anything to stick to. So you're probably not going to retain a whole lot of this. So do yourself a favor and do the metaphorical sticky side of the Velcro, which is this. It's all looking at summaries and making sure you kind of understand what you're trying to do. Okay, so now we're going to actually go to the textbook section. 5.1. Again, you see that learning objective at the top, and you've written that down somewhere. Don't forget. Now, while you take notes, what you need to be looking for are things that you think you need to memorize for some reason, and or because oftentimes this will be an things that relate to that learning objective that will help you answer that learning objective and help you be able to reach that goal by the end of the chapter. Okay. So now, before you start reading, what's important to do is actually just scroll through that chapter. And I want you to look for things like you see these bold words, not like figure 5.1, but like trioses, pentose, hexose. Those are vocabulary words. Those are probably things you're going to need to memorize. Scroll through and just, make a little mental note of them. Some people actually like to write them down in a list. You can do that too, if that makes the most sense to you. Now, okay. Sometimes you're going to get to figures. Important to pause and maybe just take account of the figures. And also, you're in the bio textbook, for instance, you're going to see this thing that says model. Mannose is a 6-carbon sugar that is similar to glucose, except for the orientation of the hydroxyl group on the second carbon. Draw the structural formula of mannose and circle carbon number 2 and the hydroxyl group. Okay, it's asking you to actually do something. You don't have to do this yet because you haven't actually learned anything about this. You haven't read the chapter, but read that over and think, okay, when I get to this point in the chapter, I need to be able to do that. That is a good, just kind of stopping point here for me. Just a place for me to check and make sure that I'm on the right track. Now, you're going to also probably see things at the end of the chapter. Again, in most science textbooks, you get this kind of thing at the end of the chapter, just kind of a check-in. So this one at the end of the chapter is almost always related to the learning objective. And in this instance, it's definitely related to the learning objective. So I suggest that you actually write this down as well. Maybe you write it down next to the learning objective. Maybe you write it down somewhere else. But I suggest that you write this down because, again, you need to understand what you're trying to be able to do by the end of this, reading this chapter. Okay? So then we start reading. So here's a paragraph about monosaccharides. It's got a few pieces of information in it. Now, if you're in Bio 141, you probably know that you need to memorize a lot of stuff. You're going to need to apply that stuff that you know, all those things that you've memorized, but the building block, the foundation here is just memorizing a bunch of things that you can then access in your brain later. So when I recommend students take notes directly onto flashcards, this is what I mean. You read this paragraph and you think, okay, there are actually three things there that I need to memorize. So here's what they are. You may have a different opinion about this, but when I read this paragraph, I thought, okay, maybe nice to kind of have a good handle on what is the molecular formula of every monosaccharide, because knowing this, having this really solidified in your brain, is probably going to be helpful to you. You know, we read those questions about drawing and modeling. It's probably important that you know what goes into that monosaccharide when you're drawing it. So open up Anki. In your deck here, you can see my deck is called Bio 141 Unit 1. And I'm making a card, asks what is the molecular formula of every monosaccharide, C3H6O3. You'll notice that I can use superscripts to write, subscripts. I can do up here, we got bold, italic, underline. You can make your text a different color. You can highlight, you can erase, bullet points, numbered lists. You can attach a file, a picture. You can add an audio recording, and you can do equation writing. There are a lot of things you can do with these cards. And if you just think, I need to memorize this thing, make it into a card. It goes into the deck. There we go. Next, I think, maybe it might be useful to understand always in your mind, these are the two smallest types of monosaccharides. Just keep in mind, what are they? They're a building block to this chapter, and so maybe memorizing them is a good idea. Okay, third thing, what distinguishes one from the other? Notice that for something like this, I reworded it a little bit. I didn't just copy and paste what was in the textbook. I actually thought, okay, what does distinguish an aldose from a ketose? Okay, this is an aldose and this is a ketose. I'm contrasting them here in my own words. But yeah. So, what happens when you get to a figure, a graph, or a chart? In high school, what did you do when you got to these parts? Most of us skipped them. Do you know why? This is actually an interesting question to ask yourself. Most test questions in high school come from definitions and terms and not with examples. And this is why. This is Bloom's taxonomy, which you might have seen before. So in high school, we're asked to remember and understand. We get a lot of match the term to the definition. We get a lot of explain osmosis. We don't get a lot of big word problems like here's a situation. What is the importance of this thing in it? That's kind of what we're looking for here. That's where we are. Bio 141, Chem 101, Chem 102, Bio 142 kind of area. Maybe even in some higher level bio and chem classes. This is where we are now. We need to be able to use information in new situations. Now, this check your understanding question, that's a situation. That is a thing that you're being asked to do. And now this is actually kind of on the brink of the understand and apply thing here, but making sure that we really understand it, we should maybe be able to apply it. So this is a way to check that you actually understood the learning objective, like I said earlier. And if you write this down before reading the chapter, like I recommended, you're going to know what to look for. This is going to be really helpful. So when it comes to textbooks, this is kind of the way that we recommend that you take notes and you absorb the reading or the lecture video or the module or whatever way you're getting presented with the material before class. So let's move on. We're going to do some little Chem 102 examples here. So Chem 102 and Chem 101, they have modules or readings or anything. They have some information that you need to take in before the day of class. And usually they're going to ask you to do like a little reading quiz on that to make sure that you really did actually read that textbook and or that module and see kind of what you needed to absorb. But on the day of class, you can preview the slides, which is also helpful. So I think the best thing to do while you're previewing the slides is look for themes you recognize from the readings. But also recognize that this is a problem-based class. So one of the things you're probably going to be doing in the class is going over example problems. So if you are in Chem 101 or Chem 102, there might be some problems on the pre-class slides. Sometimes those problems will be worked out for you already. Sometimes they won't be. So in this example in Chem 102 Spring 2025 taught by Dr. Carpenter, she's going to give you something like this on the slides. Calculating concentration of ions. What is the concentration of ions in a 1.59 m solution of KCl? Okay, so this is a pretty straightforward question. It's not giving you context and a word problem. It's just asking you to do this very simple task. If you scroll up, it probably shows you how to do it. Probably give you the um, formula that you need or something. So, you can use that but we actually recommend before you go to class, you should try to solve it. So Dr. Carpenter is going to go over it, probably live in front of the studio audience, which is yourselves in class. But it's helpful to have some understanding of actually how to do it from your reading or your module. So we recommend try to solve this problem before class. Even if you've never seen someone work out an example, you should try. Scroll up a couple slides for the formula if it's there, see if you can do it. Don't work too hard. It's okay if you get it wrong. You may not know you get it wrong, although sometimes the professors have the answers right there on the slide, so you can actually check it against theirs, see if you got it right or wrong, if the actual solution is not written directly on the slide. But just try to solve it. Make sure you do the problem on paper or in a document that you can access during class. Now, while Dr. Carpenter solves this problem during class, follow along and see what she does on the board. Ask yourself, did you do the same steps and did you get the right answer? If you deviated from her method, write down what she's doing in a different color. That's an exercise in metacognition. It's saying, what do I need to make sure that I look out for the next time I do this type of problem? So even if you did the problem wrong the first time by yourself, now that you've seen your method overlaid with Dr. Carpenter's method, you will likely remember the mistake you made and be more careful the next time you see this type of problem. So then, after class, you can look for some more example problems either in the textbook or you can go back to the pre-class slides and try to solve these again without looking at your notes. See if you can do them. Make sure that you look out for the mistakes that you are liable to make. Make sure your metacognition is high here. So, in terms of taking notes in class, if you have done your prep work, like these two things, which again made up the bulk of this workshop, you should be pretty prepared for class. You should have a pretty good understanding of what's going on. A border of that puzzle is filled in, and a lot of puzzle pieces are also filled in. So you're probably going to class with most of the puzzle already complete. You're not going to need to be like losing your mind trying to do this whole puzzle at super high speed. You can be kind of relaxed about it. So we recommend that you try to use a pen, either a digital pen or a real pen, whatever is your preference. Why? Because you can't write everything down. You have to paraphrase. And as a result, your brain has to think harder about what information is important. You have to do a live parsing of what they're saying and thinking, okay, those are the 3 words I need to write down. This is a sentence of the last 3 sentences that's important. You are summarizing in your head. You're going quickly. You're thinking, this is the important stuff. This is the important thing in this sentence and the next sentence. And maybe you're just making bullet points and writing down random words, but you are noting down the important stuff. And you are thinking in the moment about what's important, which is also a huge part of this. So it's going to kickstart the encoding process in your brain. That's why this is important. You're going to remember it better automatically without even doing active recall practice, although you still need to do active recall practice, which means flashcards and practice problems. Okay, but I'm terrified of not catching everything they said. That's normal. A lot of people are stressed about that. You got a couple options. Ask if you can record the lecture. They might say no. You need to respect that. You can download the slides or take a picture of every slide if they don't put them as a slideshow on Blackboard or something, you can do that. But make sure that you have access to the slides to revisit after class. Trust the notes you took on the readings or the videos or the modules. You have to trust yourself, and this is going to make you better and more responsible about doing the pre work before class. So use this as an opportunity to take really good notes while you read. Again, maybe you're doing that in flashcard form. Maybe you're doing that in note form. Maybe it doesn't matter the format that it's in. Maybe it's just a mind map. Whatever it is, you understand it. It makes sense in your brain. This is your deep exposure to the material. That is the thing you need to focus on. So during class, again, you're just looking for those clues. You're filling in the gaps. You're finishing the puzzle. Now, afterwards, got to summarize. After class, sometime in the day, not necessarily directly after class, but some people like to do it right after class. Find some time in the day to clean things up. Are there gaps in your notes? Fill them in using the lecture slides. Maybe those are just gaps in your class notes and you still want to fill them in using the lecture slides, even though you already took really good notes on the reading. This isn't going to hurt you. Think about how much time you're spending on it, though, because you don't want to waste that time. Come up with a 1 to 3 sentence summary of the lecture. How does it relate to the big picture? So maybe you in each class are doing a mini puzzle that all creates as a sum of all the lectures creates the larger puzzle of this class. So think about that. What part of the big picture was that class? Are you in a problem-based class? So it's chem, math, physics. Revisit each type of problem you did in class. Maybe use the pre-class slides for Chem 102 and see if you can solve them correctly without your notes. Then check again against Dr. Carpenter's work on the post-class slides. If you're a flashcard user, take some time later in the day to create flashcards from the lecture. So if you already made them from the textbook, this might just be filling in the gaps. Maybe you're using examples. Whatever it is, again, we've got Anki down in the description box of this video for you. But whatever it is, take some time to do your summaries and think, okay, what do I need to actually remember from this? And don't forget with flashcards, I hope you watched to the end of the video to hear me say this. You need to review them. You can't just make them. They have to be functional. You should go over your flashcards for 10 minutes at a time, 2 to 3 times a day. That is a half hour of studying every single day that you can do when you're just sitting there waiting for your class to start with your computer open. Sit there and go through some Anki flashcards. Bam, you've just done 10 minutes of active recall practice. That is 10 minutes of studying that you are banking. You will not have to cram because your synapses to those material that you've just learned is in your brain are be so strong. Those things are going to be in your long-term memory. You will not have to use spots in your working memory to keep them in your head for a test. You will just be able to access them so easily for those tests where you're asked to do a task that really requires you to know that stuff. And that is going to be so beneficial to you. So flashcards are amazing. But that is all we have for you today. So thanks so much for watching, and we will see you next time.